Okay, welcome back. Now let's do examples about arithmetic of quotients, rational numbers. Okay, so example. If we do addition, 2/3 plus 5/2. As we suggested, we're going to multiply the first quotient by the denominator, by the second denominator. So 2 times 2 is 4, 2 times 3 is 6. And then we multiply the second fraction by the denominator, first denominator. 5 times 3 is 15, 2 times 3 is 6. Now you see that you have the common denominator, then the result is going to be the common denominator and 4 plus 15, 19. So the answer is 19/6. Okay, this is addition. Subtraction is very close. 3/5 minus 2/3. First, you find the common denominator. You multiply top and bottom by the second denominator, so it's a 9/15 minus. You multiply this top and bottom by the first denominator, 10/15. And then the denominator is still 15, and then you use 9 to subtract 10, you get -1. So the answer is -1/15. You can write this way or you can write this way. Either works. Either works. This is the right answer. This is also right answer. You can leave whatever one as your final answer. Okay, next. Product. Product is the simplest one. 8/3 times 15/4. So product of quotients is the simplest one. So it's just 8 times 15 over 3 times 2. 8 times 15, what is it? It's 120. 3 times 4 is 12. So after simplification, 120/12 is 10. Okay, so numerator times numerator, denominator times denominator. Last example about the arithmetic of a quotient is division. So 3/5 over, make this as clear as possible, 7/9. It's a quotient among quotients. So you copy the numerator, you flip the denominator, change the quotient to be the product, and then you do the product among numerator and the product among denominator. You get 27. 3 times 9, 27 over 35. So 27/35. Okay. All right. Okay, now let's see. This is the basic example. All the computation arithmetic of quotients can be done by this way. Now let's discuss one important concept. It is actually related to the computation of addition and subtraction. It's called the least common multiples. The least common multiples. It's LCM. LCM, the least common multiples. What is the least common multiples? For example, assume we have two numbers. One is 15, the other one is 12. The other one is 12. Okay, so multiple. 15 is a multiple of this itself. And the next bigger multiple will be 30. It's a 15 times 2. And next will be 45. It's a 15 times 3. So this is times 2, this is times 3. And next one will be 60. It's a 15 times 4. And next one be 75. It's a 15 times 5. So every time you multiply by the next integer, and 90, and 15 times 6. Okay? So they are all multiples of 15. On the other hand, if you multiply 12 by 2, you will get 24. 12 by 3, you will get 36. 12 by 4, you will get 48. 12 by 5, you will get 60. 12 by 6, you get 72. This is it's not ending, it's indefinite. Okay, so this number and this number, 15 and 12, they have two chains of multiples. You will see this one as a first repeated one, first common one. And actually, if you do more, you will see there's others. If you see 120, you will, it is also the multiple, common multiple. So 60 is the common multiple of 12 and 15. And it's the first one. First one means smallest one. The smallest common multiples of the least common multiple, no S. The least common multiple of 15 and 12. 60 is the smallest common multiple of 15 and 12. Smallest, we can use another word, least. So the LCM of 15 and 12 is 60. 15 and 12 is 60. All right, so that's the meaning of the least common multiple. Least common multiple. And how do we find it? We cannot, cannot. We don't want to find the least common multiple every time by writing the long list of the common multiple. We'll do the following way. We know 15 is what? 3 times 5. 12 is 3 times 4. How do we get 60? We get 15 times 4. So you need to multiply by 4. How do we get 60? We get from 12. We get 12 times 5. So this one, you see, I have 3, but I don't. I have 3, I have 5, but I don't have 4. And this one, I have 3, I have 4, but I don't have 5. So once you combine all these factors together and do multiplication, this is 60. You just attach or multiply by the missing factor, missing factor. So for example, if you have 18 is 9 times 2. 16 is 8 times 2. Then the least common multiple of 18 and 16 is going to be 2 times 8 times 9. 2 times 8 times 9 is 144. All right? So one thing, this part is a maximum common part. It's a maximum common part. In other words, these two numbers have no common factor. We cannot get another common factor. Okay, so by this way you can get the least common factor, least common multiples, least common multiples. So another one is 16, the other one is 28. So 16 is 8 times 2, 24. 24 is 8 times 3. Okay, so of course you can write this as 2 times 8, this as 2 times 12, but we are not going to use this factorization, because for this factorization you have 2 common, but 8 and 12 still have the common factor 8. Common factor 8. So you have to, 4, they have common factor 4. So you have to factor out the maximum common factor, 8. And then you have 2 and 3. You see, this number 2 and the number 3, they do not share the common factor. They do not share common factor. Then the least common multiple of 16 and 24 is equal to 8. This one is repeated. Times 2 here and times 3 here is 48. Is 48. So this is a way to find the least common multiple. Okay? So once we know the least common multiple, how do we use them? Why are we interested in it? For example, we want to add 8/15 and 5/12. As tradition, how do we add them? We do the following thing. We multiply 8 by 12, 96. We multiply 15 by 12. So far, I don't know what it is. I just leave it there. And for the second one, I multiply 5 by 15, 75. I multiply 12 by 15, it's 12 by 15. Well, let me compute what is 12 by 15. 30, 15, 108. Okay. So it's 108. Then here it is a 96 plus 75. It's 171. 171, right? Yes. And then you need to simplify it. You need to simplify it. This one is a multiple of 3. This is also a multiple of 3. So sorry, 5, 7. So it's 3 times 57. The denominator is 3 times 60. So you cancel 3 from top and bottom, you get 57 over 60. All right, so this is the traditional way to find the sum. And in this process, you need a cancellation process, cancellation step. What happens if we use the least common multiple? We know that the least common multiple of 15 and 12 is, where is it? 60. So we need to multiply 15 by 4. So we also multiply top by 4. So it's 8 times 4 is 32 over 60. 12, we multiply 12 by 5. So it's 5 by 5 is 25. 5 by 12 is 60. Okay, now 32 plus 25 is 57. So you get 57 over 60, and that is the answer. So it's the same thing. But in this process, you save the cancellation step. You save the cancellation step. Sometimes it's not that easy to see some factor can be cancelled. Okay, so here you have to realize that, okay, 171 has a factor 3, then you can do the cancellation. If you do not aware it, you are going to leave this as an answer, which is not complete. Okay, so at this step, it's not complete. And the least common multiple will save you from this situation. Okay? So that's the usage. Okay, so this is the last part of section 1 in the review chapter. Okay, so we're going to next. You're going to do the recommended exercise, and I'm going to jump to the chapter 1, equations and inequalities, and section 1. Okay, so here is end of review chapter, section 1. And we'll move to next chapter 1, equations and inequalities. Equations and inequalities, the first section. Linear equations. Linear equations. All right. Okay. Let's first start from some basic theory. An equation in one variable. An equation in one variable is a statement in which two expressions at least one containing the variable two expressions, this is in which two expressions are equal. But the condition is that at least one expression contains the variable. Okay, and those two you have equals. Equal sign has two sides. You have left side and right side. The left side and the right side. And okay, so that's our equation in one variable. After a long time, we'll only discuss equation in one variable. And the value of the variable that makes the statement true is called a solution. It's called a solution. All right? So it may have or root. Or root. To solve the equation, we basically try to find the solution or try to find the root. So for example, if we have x plus 5 equal to 9, so you see, you have two expressions. One is x plus 5, the other one is 9. They are equal. And the left-hand side, the left side contains a variable. So this is the equation in one variable. And x equal to 4 is a root, is a solution. Because when x is equal to 4, the left side is equal to the right side. Okay? So this is a perfect example. So x is a root, or we say 4 satisfies the equation. It's just language. X equal to 4 is a root, or we say 4 satisfy the equation, or you say x equal to 4 satisfy the equation, if you want to emphasize what variable you have. Okay, and we put 4 as is the solution set. Solution set, we use the braces and including the solution, all the solutions. You have to put all the solutions. Then this is a solution set. Okay. The solution set may be empty. For example, if you have x squared plus 1 equal to 0, x squared, we know that x squared is always a positive number, plus 1 is also positive. So this one has the solution set empty. There's no solution. There's no solution. Okay? Or you have x plus 1 is equal to x plus 1. Whatever x will make, whatever value of x will make this equation correct. So this is called an identity. It's called an identity. The solution set is a set of whole numbers, all numbers. There's no need to find the solution set. It's always correct. So that's our identity. Identity just means you don't bother to find the solutions. Every point will be the solution. Okay. Well, let's see how do we solve the equation. Well, again, this is the first section of the chapter. It's supposed to be the simplest material. Solve an equation. Okay, solve the equation 3x minus 5 equal to 4. So how do we do that? How do we do that? Solution. So first I copy this and I'm going to add two sides by positive 5 to cancel this 5 from left hand side. In other words, I want only variable in the left hand side, possibly with a coefficient. The coefficient is handled the second way. So this is a coefficient. This is constant term. Okay, so this number, even though it's a number, but it's not a constant term, it's called coefficient of x. It's joined with x. But this number is isolated number. I want all the numbers in the right hand side, the variable with its coefficient in the left hand side. When you move a number from left side to right side or from right side to left side, whenever you cross the equal sign, you're going to change the sign. In other words, if in order to move it from left to right, I'm going to add a 5 for two sides to balance this negative 5. So we're going to add a 5. So it's a 3x minus 5 plus 5. They cancel. 4 plus 5 is equal to 9. Okay? So basically, I'm trying to move negative 5 to the right-hand side by adding a positive 5. We move it to the right-hand side by adding to positive 5. Adding a positive 5. Okay. And then it has coefficient. We're going to handle the coefficient. We're going to divide two sides by 3. The left side and right side. So 3 canceled. I'm trying to cancel this coefficient. 3 cancel, you get x. 9 over 3 is 3. So this is the solution, the unique solution. So the solution set is braces 3, and that's it. Okay, so this is the first and important example. Okay, so this example is not special. It represents a class of examples. What is a class of this example? Solve a linear equation. What is a linear equation? Ax plus b equal to 0. This is a linear equation. Here we require a is not equal to 0. If a is 0, you see here, there's no variable. That's not what we want. Linear equation ax plus b equal to 0. Okay. To solve this, what do? We're going to move this constant term to the right side, like this one. When we move it across the equal sign, it becomes minus b. Or in other words, this is one way to explain it. I move this number to the right side, it's changed to be negative b. Or second way to explain it, I subtract b from two sides. So the first explanation, you can say it, I move b to the right side to get a negative b. Whenever you cross the equal sign, you change the sign. A second way to explain it, subtract b from two sides. When subtract b from left side, b cancel b. When subtract b from right side, 0 minus b is negative b. So either way, two explanations about the same movement step. And then we're going to divide two sides by a. We will get a negative b over a. Negative b over a. Be careful here, we assume this a is not zero, so this is possible. We can do the division by a non-zero number. So this is important. Okay, so that's a complete solution of a linear equation. So what did we do? We keep x with its coefficient in the left-hand side. We keep all the constant numbers in the right-hand side, simplify it, and divide by the coefficient of x. Okay, so let's do one example. Solve this equation. Solution. Okay, very good. For this equation, you have 1/2, 1/3. For the computation purpose, if you have the denominator, for me, I'm going to multiply this equation by the least common multiple of the denominator. I don't like the fractions. I want numbers, integers. So I'm going to multiply two sides by 6, 2 and 3. The least common multiple is 6. So each term I'm going to multiply by 6. This term times 6, okay? I'm going to write this step, and eventually you don't need it. Minus 6 times 4 is equal to 6 times 1/3 2x minus 1. And then 6 times 1/2 is 3. 6 times 4, 24. 6 times 1/3 is 2. Okay, so by this multiplication, I have an equation with all integer coefficients. I have equation with all integer coefficients. I'm good at integer calculation, not fraction calculation. Okay, so that's the purpose to do that. Don't forget 6 times 4. Don't forget 6 times 4. Okay, then we use distribution property. So 3 times x, 3 times 5, minus 24. 2 times 3x, 2 times 1 is 6x minus 2. And we continue. Here is a 3x. 15 minus 24, minus 9, 6x minus 2. Okay. And then remember, I want x in the left-hand side, so I'm going to move this to the left-hand side. So you're going to subtract 6x. 6x on the right-hand side is positive. No sign means positive. When we move to the left-hand side, it becomes negative. And negative 9, we are going to move it to the right-hand side. All the numbers, constant numbers, will be on the right-hand side. So it's negative 9. Move to the right side, it becomes positive 9 and minus 2. Okay, so negative 9, move it to the right side, it's positive 9 and minus 2. This minus 2 is here. It's copied here. 3x minus 6x is negative 3x. How do I get negative 3x? 3 minus 2 is negative 3. 9 minus 2 is 7. So it's negative 3x is equal to 7. And then we divide two sides by negative 3, the whole coefficient, which is negative 7/3. So the solution set is braces negative 7/3. So for the solution set, we always use braces, no other parentheses or bracket. Okay? Okay, very good. So this is the first example about solving a linear equation. We will have more examples in the next lecture video. Okay? Thank you very much. Try to do as many exercises as possible. Okay? If you have any question, let me know. We can either get email discussion or we can have the video chat discussion. Okay, thank you.